So in this screencast, I want to go through a problem that's in your labs and try to emphasize how you construct a query using joins by going through the solution to this problem and approach to finding a solution to this problem in a pretty lot of detail. So the problem is it's CSU4 in your lab. Report on graduate enrollments in 2004 in agriculture and biological sciences for any university that offers graduate studies in both disciplines. Report one line per university with 2 graduate enrollment numbers in separate columns, and so sort the universities in descending order by the number of agricultural graduate students. So this is a pretty complicated problem. Hopefully you're familiar with the structure of the CSU database. Let me just, the 3 relevant, step 1 really in terms of doing any of these queries, as I've said before, is to make sure you understand the database and then determine the relations that contain the relevant information that you need to solve a particular problem. So here, if you look at the problem statement, you're going to need enrollments, okay? So graduate enrollments, and you're going to need what disciplines they're in, and you're going to need the university. So if you look at the database, you basically see that you're going to need the disciplines table, because that's got the name of the program in it. You're going to need the discipline enrollment, and that's got the campus ID and the discipline and the enrollment, the graduate enrollment there. And then finally, you're going to need the campuses, because you're going to need the name of the campus. So that's step 1. That can take some time. I don't want to trivialize it, but that's the first step. Now, since the problem looks pretty complex in terms of you have to get both the agriculture and the biological sciences in separate enrollments in separate columns, what I want to do is I think it's probably a good idea to start out with a simpler problem. And so what we're going to do here first is we're just going to try to solve the problem for one discipline, say agriculture. So here's what the problem would look like now. We're just going to get the graduate enrollment in agriculture for any university that offers graduate studies in agriculture. And we're going to report one line per university and sort the universities in descending order by the number of graduate students. Note, and this is important, we're still going to need the same 3 tables. So we're simplifying the problem in some sense, but we're keeping enough complexity that hopefully it will give us some insight into how to solve a harder problem. So here's the solution for the simpler problem. We're going to, again, what we want to be able to print out is the campus and the enrollment. And so we're going to need the same 3 tables, as I mentioned. And it's pretty easy to think about, I think, hopefully at this point. We're going to want to link the 3 tables. And so we're going to do that with this equality in the where clause and this equality in the where clause. So those will effectively create joins, although we're not doing it explicitly here, we're just using the where clause to do that. And then the other relevant stuff that we're going to want to filter the resulting tuples by are we're going to want the year to be 2004, the name of the discipline to be agriculture, and the graduate enrollment to be bigger than 0. And we want to order by the graduate enrollment. So if you built this into, if you put this query into CSU4, you'd see that this seems to work. And if you look at the tables and verify, you can see that you're getting the right answer. So now, given this, we want to use joins. So I already hinted at how we're going to do that. We want to make things clearer. We want to use the joins in the from clause, joining these 3 tables together so that then in the where clause, we only have the filter for the specific problem that uses that table. And in this case, that would be that the year is equal to 2004, the name is equal to agriculture, and the enrollment is greater than 0. So here's how we do that. As I already mentioned, we want to basically use the some of the conditions in the where clause and explicitly create joins in the from clause. So if you think about it, what we're going to do is we're going to join disciplines with discipline enrollments, and the way we're going to do that is if you look at the attributes, we'll do it from the discipline ID in disciplines and the discipline attribute in the discipline enrollments. And for right now, we're going to leave campuses off to the side. Notice when we do that, so we're only having this one join, we're still left with this the campus ID in discipline enrollments and the ID in campuses. So the next step is to use that and do another join. So now we're going to have, like in the previous one, we did a join here between disciplines and discipline enrollments, and this was the condition, and then we join that with campuses, and this is the condition. Now we've got a pretty clean solution here where all the table formation is done in the from clause, but now the filtering of which tuples we need to get is done in the where clause. So we've made a nice clear distinction. It's easy to read and understand what's going on for anybody who has to look at this query at some time in the future to maybe modify it or use it for some other modify it for some other purpose. So now let's get back to the original problem. We're going to take our simpler problem and see how we can piece it together. Well, in some sense, I mean, we just if we have the solution for agriculture and we have the solution for biological sciences, it seems like it should be pretty easy to put those two things together. So let's see if we can come up with that. So one thing we can do is, again, we have the same relations, and let's look at what we did for agriculture. For what we did in the from clause is we effectively created a table, a relation that had all these attributes in it. So we had the two attributes from the discipline table, the attributes, the 5 attributes from the enrollment table, and then the attributes from the campus table. So we do the same sort of thing with the biological sciences, but we need to tie them together. So how are we going to tie them together? Well, one thing that would be a good bet is just because we want one campus per line, is we're going to use the campus. We're going to use this relation to tie the two things together. So here we are. We've got the relation using joins for agriculture. We create something that looks like this. We have the relation using joins for biological science. Okay, something like that. So you just take the code and effectively, in some sense, copy it in our heads right now. This is just conceptually. And now we have to tie them together by doing the join sequentially. So what we're going to do is we're going to call, you'll notice that for biological sciences, we're going to call the discipline X and the enrollment Y, table Y, and the campus enrollment will still be C, because that's what we're going to use to put things together. So we're going to do, this is what we did in solving the agricultural problem, and now we're going to take that, do the first step of solving the agricultural problem in the biological sciences problem with X and Y, and then we're going to take those two things and join them together on campus, with the campus table. So let's look and see the next page, see what that looks like. So here's the final answer, and I suggest you really spend some time looking at this and seeing why it all works. Notice the big picture, first of all, though. We have what we want to write out in creating the final table. So we're just going to have the campus, the enrollment for agriculture, and the enrollment for biological science. And notice the structure. So this is very nice in terms of conceptualizing what's going on. We're doing all the table joining up in the from clause and getting the resulting table that we need. And then in the where clause, we're doing all the filtering, and we filter on year in both copies of the enrollment table. And we're going to filter on the discipline in both copies of the discipline table, relevant disciplines, agriculture in one and biological science in the other. And then we're going to make sure that both the graduate enrollments are greater than 0. And what goes on in the join, up in the join, is exactly what we talked about in the previous slide. First, we're going to create the join that represents the solution to the agricultural problem. Then we're going to create the join that's the partial solution to the biological sciences problem. Then we're going to join those two things together, the solution to the ag problem, the solution to the biological sciences problem, and we're going to join them together using the campus IDs. Note the clarity of the code. I mean, I think that's important, and maybe it helps you see why you would want to do this. You can solve this problem just using the 3 tables, actually 5 tables, 2 copies of both the discipline table and the enrollment table, and just using the where clause to tie them all together. But you get a much more, it's much harder to see what's going on. Whereas here, it's totally obvious, I think, what's going on. This is where all the joining of the tables takes place, and this is where the filtering goes on. So hopefully you found this useful. I think I've crammed a lot here into just a few minutes of screencast. So you may want to, I hope you'll take your time and make sure that you understand how this all works on a step-by-step basis. Feel free to answer questions to ask questions in class.